Hello everybody. We are going to go through the 7172 quiz review in advance of taking the quiz here. That'll be due Sunday night here. So starting with number 1 here, looking at simplifying the expression, showing your work here. First of all, this piece right here, that is going to equal cosine squared by one of our Pythagorean identities. If we take a look here at the formulas here, that one would be part of this one right here. These two guys are the same formula here. So moving back, so we have that. So now let's go ahead and rewrite this in terms of the kind of definition. So I'm going to get 2 times 1 over cosine x for secant, sine x over cosine x for tangent, and now I have this cosine squared x, and I can put that over 1 here. So now what happens is that these two cosines in the bottom give me a cosine squared, and that will reduce that to 1. So now I have 2 times 1 times sine of x times 1, and that's just going to give me 2 times the sine of x, and that one is done. So again, using that Pythagorean identity was a key move there. Now number 2, I see I have these kind of two fractions, one of which is a fraction of fractions, but they're related. Tangent and cotangent are cofunctions, and then cosecant and 1 over and sine are cofunctions. So I'm going to work on these individually here, because if I go ahead here and tangent is going to be sine x over cosine x, and then cotangent is cosine x over sine x. And if I take the top fraction and multiply by the reciprocal of the bottom fraction, and I get sine squared x over cosine squared x, which is just tangent squared x. So that side is done. I'm going to switch colors. And again, I'm going to work on this other side. So similarly here, I'm going to do this one a little bit different. This one is cosecant x. 1 over sine is cosecant x as well. And cosecant over cosecant is just 1. So this is just plus 1. Plus 1. Final answer is a plus 1. And I could rewrite this because there is a tangent identity here. Let's take a look. This could actually equal secant squared because of, again, we can use which one here is right here. We could use this guy right here. So again, one of our Pythagorean identities here. So that allows us to not say 1 over tangent, or tangent plus 1, but secant squared is our final answer there. Moving on here, some similar type problems as we go. I'm going to go ahead here and do something we've done a couple times here with this type of problem here. I'm going to break up this 2 to 1 plus tangent squared x all over secant squared. And then there's a minus 1 that's trailing the whole thing. Okay. Now, like we just did with the previous problem, we have 1 plus tangent, and that actually becomes secant squared using our formulas. So now what's going to happen is we're going to break up the numerator. So I'm going to have this guy right here, and so that's going to be 1 over secant squared plus if I go ahead here, I got secant squared over secant squared. I'm just going to write that down. I knew you could simplify that quicker. And we still have that minus 1 dangling behind. So now finally here, this first part just becomes cosine squared. And again, if we want, we can go back and look at our formulas. And right here is what we're using. So again, I'm going to erase these guys. So we're going to use this relationship, the co-function relationship. And going back here to this piece, oh, wrong page here. And we also know that secant squared over secant squared is 1, and then I have this minus 1, and these guys cancel, so I'm just left with cosine squared of x. Okay, moving on here, we're going to use some negative angle formulas here, and again that would be these guys here, and again these are based on partly because whether the function is odd or even. So if we go back to here, so first of all, cosine of negative x is equivalent to cosine x. Tangent of negative x gives me negative tangent x. And this one here is going to be this is going to be sine of negative x using the cofunction relationship, and then that's going to be plus negative sine x using the negative angle. So now let's go ahead and break this thing up. Cosine x over 1. This is going to be negative sine x over cosine x, and then plus sine x. Okay, so now these cosines will cancel. I'm going to get negative sine x plus negative sine x, which is going to be negative 2 sine x. And that one is done. Moving on here, verifying is getting one side to equal the other side or changing both sides. But again, it's kind of some intuition here, some logical intuition. Now the first thing I'm going to do is I'm going to take this cosecant squared, and I could go ahead. I know I need to get a sum, so I could switch that to 1 over sine squared, but that's not really going to help me get a sum. So I'm going to go back to the formulas, and again I have that cosecant squared equals this. I'm going to take this guy and work it in here. So I'm going to write this as secant squared x, and then that was 1 plus cotangent squared x, and then I'm just going to work on that left side. So now I'm going to distribute because I have a monomial times a binomial. So I'm going to get secant squared x plus secant squared times cotangent squared. Now this matches that, so I'm in pretty good shape there. So I'm just going to leave that guy alone. And over here, this is 1 over cosine squared x. Cotangent is cosine squared over sine squared. These cancel, so I get secant squared plus 1 over sine squared x. And that's going to be secant squared x plus cosecant squared. And when you get one side equal to the other side, then you're considered that you have verified the identity. Over here with number 6, again, I'm going to go ahead and use a cotangent, and kind of do the reverse of what I did here. Or in a sense, yes. Again, because I have to get a subtract. Okay, so again, looking at my formulas, again, I'm going to bring this minus over here, and so my cotangent squared will equal cosecant squared minus 1, because I do need to kind of work toward the other side. And so I'm going to go ahead, and this is going to be, this is going to be cosecant squared x minus 1 over cosecant, which is a good thing. Alrighty. And now I'm going to do that, I'm going to break up that into two fractions. So I'm going to go here. And so that's going to be cosecant squared x over cosecant x, and then minus. When I do this, I'm going to get 1 over cosecant x. This changes that power to that, so I get cosecant x, which is what I have here, minus 1 over cosecant. Again, if we look at our formulas here, 1 over cosecant is right here. That's going to equal sine of x. So this is sine of x, and now this equals that, so we have verified. Moving on to using the angle sum or difference formulas here. First of all, we have to figure out what a way to break up 285 is either a sum or a difference. I see this as 150 plus 135. These are both in the second quadrant, so we have to be careful because cosines are going to be negative and sines will be positive. So keep that in mind. So I'm going to go ahead and rewrite this as the sine of 150 degrees plus the sine of 135 degrees. And again, using our formula, again with the addition with sine, we're using this guy right here. So it's going to be the sine of the first times the cosine of the second plus the cosine of the first, sine of the second. So I'm going to go ahead and put that in action here. So it's the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. Okay, now using our unit circle knowledge here, sine of 150 is 1/2. The cosine of 135, that's a 45 multiple, so but that'll be negative. Cosine of 150 is going to be negative root 3 over 2. And then the sine of 135 is going to be positive root 2 over 2. Now if you take a look here, both of these groups will have a denominator of 4. And now we just multiply the numerators. And that can be our final exact value, still in radical form. And then moving on to the last one here. Again, using the difference formula, so we don't have to do the work here. So again, the tangent formula for an angle difference, again, comes from the difference formula is right here. So we're going to apply this here. Again, if I sent out this formula sheet there in a little bit different form, go ahead and have that out as you go here. So this is going to equal the tangent of 135 minus the tangent of 30 over 1 plus the tangent of 135 times the tangent of 30. Now we could have the order different if we wrote. No, I guess we can't because this order was already set, and it's subtraction, so order matters. So now here again, a while ago there was the tangent additions to our unit circle. So the tangent of 135. Now again, remember 135 is out here in the middle. That's going to be -1. 30 degrees tangent here is going to be 1 over root 3. And we'll have to rationalize that by multiplying root 3 bottom, root 3 in the top. So I'll just leave that as is. Down on the bottom, we're going to have 1 plus -1 times, and again, we're going to have to rationalize that. So I'm going to just do that now because I don't have a ton of room here. So now let's go ahead. I'm going to work horizontally here. And so I'm going to get in the top -1 minus root 3 over 3. In the bottom, we're going to have 1 plus. Oh, I guess that'll be a negative root 3 over 3 as well. So now with these problems, recall, we cannot have a radical in the denominator. So again, I'm going to take this guy and multiply by its conjugate, called a complex conjugate. So that's going to be 1 plus root 3 over 3. And what I do to the bottom of a fraction, I have to do to the top in order to keep them equivalent but looking different there. So now we're just doing our foiling now here. So if I'm going to, in the top, I'm going to get -1. Let's see here. I'm going to get -1. I'm going to get negative root 3 over 3 when I do my first and outsides. Then when I do my inside last, I'm going to get another negative root 3 over 3, and then minus 3 over 9, which simplifies to 1/3. In the bottom, I'm going to get 1, middle terms cancel, and I'm going to get 3 over 9, which is also 1/3, which also gives me 2/3. So now cleaning up the top, I've got this plus this, so that's going to be a 4/3 negative. Here I'm going to get a negative 2 of these root 3 over 3's. And I'm going to multiply by the reciprocal of my denominator and then redistribute here. So this should kind of clean things up here. So a negative times a positive here is a negative. The 2 is reduced, the 4 to a 2, so I get -2 here with this first one here. So let me kind of just change colors here so you can kind of see. So if I take this times this, I get this guy here. And if I go ahead here and I take this times this, the 2's cancel, the 3's cancel, so I get minus root 3. And that's my final exact value. Hopefully this helps. Have this done and checked before you work on your quiz. And again, remember, during the quiz, you can have any resources available.